Hello everyone, the DTSC-200A is a versatile controller for automatic power source transfer, ensuring reliable operation in critical facilities like hospitals and data centers. It supports various transition modes and customizable features to meet diverse application needs. In this video, I'll be focusing on its closed transition functionality. Have you ever thought about what happens when the power goes out in a hospital during surgery? Or how businesses manage skyrocketing energy costs during peak hours? And what about ensuring your data center stays safe and uninterrupted? These are critical challenges that demand reliable, seamless solutions, and that's where closed transition technology comes into play. It helps businesses optimize energy costs by seamlessly transitioning to generator power during peak hours, unlocking significant savings while ensuring uninterrupted operations. In environments like hospitals, closed transition technology ensures an uninterrupted power supply, enabling a smooth switch to a reliable source when performing a difficult operation to save a patient's life. This solution is a must-have for data centers where daily backup power tests are a requirement. It lets you run the test without any power outages. A closed transition in an automatic transfer switch refers to a method of transferring electrical loads between two power sources without interrupting the power supply. When a signal is received with a power source change command, the DTSC-200A controller checks whether the two sources are synchronized. If so, the breaker S2 is closed, and for a short time, default maximum 100 milliseconds, the breakers of both sources are closed. Then breaker S1 is opened, and S2 is the power source. Let's move to a real device. I will show you how to set up breakers parameters in Toolkit. Go to Parameter, Configure Application, Breaker. In this section, you can select the type of transfer. You have three options to choose from: standard, delayed, and closed. There are other parameters here that you can adjust. More details about them can be found in the documentation, the link to which is provided at the end of the presentation. In order for the switching to be safe and not cause any disturbances, the voltage and frequency of the generator must be perfectly synchronized with the grid. Mismatched parameters can lead to damage to the installation or equipment. By monitoring the phases, we are able to switch the power source correctly. In-phase monitoring may be used with open, delayed, and closed transition switches. However, let me use a simple example here. This function may be used to improve the transfer with open transition switches. An open, standard, transition transfer switch is the simplest and most commonly used ATS. It may only take on two positions, connected with source 1 or connected with source 2. If it transfers a load, this will be performed according to the break-before-make process, which means that the load will be disconnected from the previous source before it will be connected with the next source. This results in a dead time of approximately 160 milliseconds, depending on the ATS, during which the load is not connected to a source. If you use in-phase monitoring in this case, you can transfer safely between two sources with minimum risk of damaging the running equipment, as the function can switch with nearly 0-degree phase difference. To configure this on your device, go to Parameter, Configure Monitoring, In-Phase Monitor. Here, we can enable the monitoring function in parameter 4570. Below, there are parameters indicating the range within which the measurement should fall to ensure compliance. The remaining parameters are described in the documentation. Some utilities require that if you want to use closed transition, then both breakers can be closed for a maximum of 100 milliseconds. This function has been tested, and if you use breakers that can open as quickly as 50 milliseconds, then the controller will make sure the maximum parallel time is not exceeded. If the utility allows for longer parallel time, then we can use a special function called extended parallel time. This can allow us to soft-load a generator, for example. So, in this diagram, some external synchronizing device, EasyGen or some other controller, is giving the DTSC-200A a signal to stay parallel for some time to make the soft-loading possible. Example situation of error handling. A transfer from source 1 is initiated, and the transfer switch is in overlap position. If the maximum overlap time has expired and the Logix Manager function extended parallel time is false, the alarm overlap timeout appears, and the unit tries to open the transfer switch from the previous source. If this fails, The unit detects an opening failure from the previous source, and the alarm fail to open appears. Now, the unit tries to open the transfer switch from the new source. If this fails as well, the unit detects an opening failure from the new source and enables the shunt trip enable flag, 20.12. This flag remains enabled until the switch is opened and the failure has been acknowledged. In such a situation, it is necessary to provide an external circuit breaker to disconnect the source from the load to prevent a continuous parallel time. In this case, it is possible to configure a discrete output of the DTSC-200A to energize when the shunt trip signal is enabled using the Logics Manager. The DTSC-200A provides a shunt trip enable signal, which is enabled if the unit fails to open the transfer switch from both sources. In this case, it is possible to configure a discrete output of the DTSC-200A to energize when the shunt trip signal is enabled using the Logics Manager. The discrete output will then open an external circuit breaker to disconnect the source from the load. If you want to configure this flag, go to Parameter, Configure Inputs Outputs, Outputs 1 to 6. After navigating to the output screen, we can program, for example, output 2 as a signal for an external breaker. In the Logic Manager, we should connect the shunt trip enable flag to the input so that it triggers the opening of the external breaker in the event of a transition fault. You can use the QR code or link to go to the documentation page. Thank you for watching.